Okay, so today what we're going to do is learn about solving linear equations. Okay, so this is in the MyLabs Plus. This corresponds to chapter 1, section 1. So this is section 1.1. And what are we doing? We are solving linear equations. However, I find that in your typical math class, we tend to completely gloss over the vocabulary and sort of expect students to pick up what we're laying down. And we might throw new terms at you routinely and just assume that you guys know what they mean or know what the differences between the terms are. Okay, so I want to sort of clarify and start this lecture with some vocabulary so that it doesn't sound like I'm speaking some sort of alien language. Okay. So the first thing that I want to talk about is, up to this point, we've been talking about algebraic expressions or expressions in general. And an expression, as we've used them, are just a statement or a phrase that just contains numbers, variables, and mathematical operations. So a statement containing numbers, and we call numbers constants now, variables, operations. Okay, we said that we can simplify or evaluate these. Right. If we have an algebraic expression that is an expression that has variables, we can only evaluate them once we've assigned a number to the variable. Okay, and then we can substitute that variable in, or the number for the variable, and then we can evaluate it, right? Just solve it like we would a numerical expression. Well, today we're learning about equations, and these are a statement that two algebraic expressions are equal in their value. So the simplest kind of equation that I can give you would be this. 2 is equal to 1 plus 1. Again, if we just throw back to the definition, 2 is equal to 1 plus 1 is a statement that the expression on the left-hand side, so I'm going to put LHS for left-hand side, is equal. So equations have an equal sign to the statement on the right-hand side. And notice that even though this is just a numerical statement of the number 2, it has the same value as 1 plus 1, even though these look different, right? They're different symbols, they're different numbers. But when you add them together, the entire right-hand side, it has the same value as this side. Okay. So separately, this would be an expression, and this would be an expression. But when you put an equal sign between them and say that these have the same value, that's what makes it an equation. Okay, another example would be something like, let's say 2 times 10 plus 5 is equal to 25. Again, the expression on the left-hand side is equal in value to the expression on the right-hand side. right? So if we were to simplify the left-hand side and actually multiply this out, 2 times 10 would be 20. 20 plus 5 would be 25. If you were to simplify this side, it doesn't change the truth value, right? It doesn't change the truth of the statement, because if we simplified this, we would still get 25 is equal to 25, and that checks out, right? That is a true statement. Okay, but we won't necessarily always get equations that look like this. In fact, we're going to deal with equations that have variables in them, and those are a little bit more difficult to interpret, but it essentially has the same sort of feel to it. So let's look at an equation that has some variables. So equation with one variable. Okay. Let's say I had x plus 10 is equal to 28. Okay, so I've set up this equation with a single variable x. And what I'm saying by writing this equation down is that the left-hand side, so I'm going to put LHS, is equal to the right-hand side. So this whole thing is equal to 28. Now, some of you guys might already in your head, after I've written this down, have already jumped to the conclusion that this, the answer to this problem is blank, right? You have the answer already in your head, and that's fine. But sometimes you don't want to let your brain get away from you. What we say when we want to figure out the answer to this problem, we're going to say the solution to an equation is one or more, I spelled or, or more number we assign to the variable that gives a true statement. Okay, well, that's just a verbose way of saying what number do I need to plug in here so that that number plus 10 gives me 28. Can anybody guess what this number has to be in order for us to have a true statement that a number plus 10?
18.
18, right? So what we do is we say that we can write this in two ways. So we can write the solution in two ways. The first way is writing x is equal to 18. I'm going to put a here. Or we can say that the solution set given by these curly braces is 18. So just as a note, curly braces, these symbols, sort of like squiggly parentheses, indicate a solution set and may have 0, well, let's say may have no solution. We would call that empty. One solution or many solutions. But to start us off, you know, the kinds of equations that we're going to be working with will only have one solution. So let me sort of underline that. For now, we're just going to be dealing with one solution equations. So I tell you the two ways to write the solution because if you know, if I was grading most of your work by hand and you were to write it down on a piece of paper, if you wrote the solution like this, I would be completely okay with that. But in MyLabs Plus, a lot of times they'll just give you the curly braces and a blank box to enter the answer. In that case, you would just write the number as your solution. Okay, so again, in your homework system in MyLabs Plus, if you see the curly braces, just type the number. Do not type x equals the number. Okay, we would call this set notation or solution set notation. Okay, let's look at another equation. If I gave you the equation y minus 13 is equal to -3, can anybody tell me what the value of y is? Just by looking at it, really.
Positive
Like,
16.
You think it's what?
16, 1, 6.
Okay, let's try that out. So here are my proposed solutions, right? We're just sort of looking at it and thinking about this problem. So my first proposed solution is the number 16. Okay. Let me see. Make sure that's nice and crisp. Okay. If this solution works, then I should be able to substitute it into this problem and get a true statement. So let's check.
No, I think I make a mistake.
Yeah, I think so, but
I
the
think
mistakes are
positive 10. I'm sorry.
Oh, okay, good. But let me just go through that mistake first, because like the mistakes are where we learn, right? 16 minus 13 is equal to -3, and we don't know if that's true or not. But when we simplify, if we simplify the left-hand side, 16 minus 13 is 3. And then you ask yourself, is 3 equal to -3? Are those the same value?
No.
No. So since this is not true, then 16 cannot be the solution. Okay, so we have another proposed solution, right? So we can check to see if 10, just plugging that into the variable here, 10 minus 13, is that equal to -3? Okay, again, there's only stuff to simplify on the left-hand side of this equation. So when I simplify this left-hand side, 10 minus 13 is what? Well, that's -3. Is that equal to the other side, -3?
Yes.
Well, yeah, those are the same value. And so that means that the equation is true. We have an expression equal in value to the other side of the expression. So that checks out. That means that the solution to our equation is x is equal to 10.
Y is equal to 10.
Yeah, my bad. Y is equal to 10 because y is the variable we're using here. That will routinely happen to me, and I assume it's going to routinely happen to you guys. X just tends to be our favored variable in math, so I always forget to use different letters. All right. Does anybody have any questions about this process?
Yeah, if that happens to us, is it counted wrong?
Well, in MyLabs Plus.
No, like with you for our quizzes.
Well, the quizzes are multiple choice when I give them, right?
Oh, okay.
In MyLabs Plus, they'll ask you to put this in solution set notation. So you would write this as just 10. So you wouldn't have that problem. So in my labs plus. Yeah. But no, I wouldn't count that wrong. If you accidentally swap the variable out for a different letter, it doesn't change the essential nature of the problem to me. So if you did the process correct, but then you called the variable x at the end, I'd give you full points.
Okay.
Okay, cool. Let's look at something else. Let's think about this equation. 3x is equal to 33. Okay. Without doing anything, just looking at the problem, just writing it down, can anybody just sort of guess or divine what the answer to this has to be? What is x equal to?
11.
Yeah. Yeah, is anybody confused as to why we got 11 for the solution here? Okay, so recall that 3x is equal to 3 times x. That when you have a number next to a variable, which I think I mentioned this, but I didn't write it down. The number next to the variable is called the coefficient. The coefficient is multiplied by the variable. So whatever the variable's value is, when I multiply these two numbers, I should get 33. Well, if I'm solving this puzzle, that means that x has to be equal to 11. Anybody have any questions about that one? Okay. So I'm really, you might think at this point that these equations are really simple. Obviously, we're going to do something more difficult, aren't we? Yes, that's true. But really, I want to emphasize here that this is all we're doing. We're just trying to find the value of the variable that makes the statement true. That's all we're doing when we're solving equations. So once we get more operations in the mix, it does get a little bit more convoluted, and you have to slow down and think about some stuff. But essentially, we're just trying to find the value of x, or the value of the variable that will make the statement true. Okay, so let me give you another sort of, just to prime your brains. Negative 2x is equal to negative 44. What is x? And then
22.
Yeah. I'm just going to say, recall negative 2x means negative 2 times a number. And the solution is 22. Because again, we can check ourselves before we wreck ourselves. And if we can substitute this back into the original problem, negative 2x is equal to negative 44, what I can do is take this value, substitute it into the expression, or into the expression on the left-hand side. I should get negative 2 times 22. And I'm asking myself, all of myself, is that equal to negative 44? And sure enough, when I simplify the left-hand side, I get negative 44 is equal to negative 44. And since that's true, this has to be the correct answer. Okay, so up to this point, does anybody have any questions, comments, or concerns? Is it feeling like I'm lulling you into a state of a false state of security? All right. Well, let's think of something a little bit more challenging. What about 1/3 x is equal to 9? Can anybody tell me what the value of x is? And just as a hint, recall that 1/3 x is the same thing as 1/3 times x. So what number do I need to multiply here by 1/3 so that I get 9? I can see some of you guys working it out on paper, but what I want to ask you really is, can you just tell by looking at it what the answer is?
I'd say 3.
Somebody said 3?
Yes.
Okay, so I'm going to write that down as a proposed solution, right? So what I'm trying to get you to do is like just guess some answers and see. I'm trying to prove to you that sometimes we can guess the answers and get it right, but other times when we guess, we're going to get it wrong. So we can't rely on just guessing or just feeling what the answer is. So our proposed solution, the first one we're going to go with is 3, right? And we're just going to try some things out. I want you to feel comfortable to just throw some stuff together, try it out, and if it doesn't work, walk away from it. Do not feel so attached to it that you just can't let go, okay? So we're just gonna say, okay, let's play around. I don't know what the answer to this is, and I don't care. It doesn't make me a bad person. I'm gonna throw 3 into the mix and see if I get a true statement. So I'm gonna check, does x equal 3? And I'll do that by writing 1/3 times 3 is equal to 9. And I don't know if that's true, so I'm gonna write a little question mark above the equal sign. Okay, well, how do I multiply fractions? I need 2 fractions. So I can write this one as 1/3 times 3/1. And then I say, okay, well, that might be equal to 9. I'm not sure. And as I continue simplifying, I'm just going to multiply straight across because that's how we multiply fractions. I'll get 3/3. And I'm not sure if that's equal to 9 either. But then when I simplify the left-hand side some more, 3 divided by 3 is 1. And I get this statement that 1 is equal to 9. Is that true? Are they the same value?
No.
Nah. So since that didn't work out, this cannot be the solution. But it was a good attempt, right?
It is 27
Yeah.
times 27.
Yeah. And so maybe if we were working through this, you could see that at some point of simplifying this, we're really getting that this number 3, let me go ahead and highlight it. This number 3 ends up on the top and gets divided by this 3 that's right here. Right? So whatever we guessed is going to be divided by this 3. So you might be saying, okay, our proposed solution is 27. We can check that one out. So let's check if x equals 27.
Yeah.
And that one, it sure does work. So we can say 1/3 times something. We're just gonna plug the 27 in there. Does this equal 9? And since multiplying by 1/3 is like dividing by 3, if you went through the whole process, you would write 1/3 times 27/1. That would simplify into 27/3, and then that divides down to 9. So we would get 9 equals 9, which you guys can't see. And that for sure is a true statement. So that tells us that our solution is x equals 27, because that's the answer that when we plug in to the original statement, we get our true statement. Does anybody have any questions? Okay, so if you're concerned right now, right, that's exactly how you should feel, because like the question in your mind should be, well, Mr. Aguilar, you've showed us how to do this and it makes sense, but you haven't really showed us the systematic steps for how you would go about guessing 27 or working out that the answer is 27 in a way that I would feel confident about, right? And that's I know that I've just made that complaint. It's a completely valid complaint. So let me give you the strategies, the rules that are going to help you get this answer in a systematic way so that you're not left like wondering, what the hell do I even do on this problem? Okay. All right. So these are going to be the principles of solving equations. Solving more difficult equations requires a more general and systematic process that's going to work every time. And so this is the analogy that I want you to think about. Solving equations is like balancing a scale. That if I have a scale and my drawing is not going to be that good, let's say that I have this there and it is sort of attached somehow to this thing. There's my stand. There's my other scale over here, my little basket. Just so that there we go. There's my scale. That if I put that these two things have to be equal in value, right? That if I have, let's say I have +5 over here and +5 over here. Let's say 5 pounds or 5 kilograms, whatever. That the scale is going to be balanced. But as soon as I take this side and let's say that now my scale, okay, here's my drawing. There's my +5. Here's the original +5. Let's say that I added 10 to this side. What is the total weight of this side now?
15.
Yeah, the total weight is 15 units of whatever, pounds, grams. But in any case, this side of the scale is going to be lower now. I've changed the problem. I've changed the equation sort of by doing something to one side. And if I want to balance it back out and have 15 pounds on both sides, well, I have to add 10 to the other side too. So the scale will be unbalanced if I only do something, add weight to one side of the scale. Okay, so this might seem like a silly analogy, but it's going to be extremely useful as we think about solving equations, because the first principle I'm going to give you is called the addition principle. So solving equations. The addition principle. The addition principle says that we can add or subtract any number to an equation on the left-hand or right-hand side, it doesn't matter, as long as we do the same thing to both sides. Okay, so here's my sort of illustration of that. Like I said, if I had the expression, let's do that expression that I had before. 2 times 10 plus 5 is equal to 25. Okay. I have this expression on the left-hand side, and it looks different from the expression on the right-hand side. Left-hand side, right-hand side. But we know that if we were to simplify the left-hand side, these values would be equal. Okay. Well, if I go ahead and let's say add 13 to this side, what will the value of this be now?
38.
Yeah. Well, if I did that, then I would get 38 is equal to 25. And that would be unbalanced. And it wouldn't be a true statement anymore. So what I need to do to remedy that is I'm just going to add 13 to the other side. And then notice that I just added a random number to one side, right? I didn't put any thought into it. It could have been any number. But once I add 13 to this side, I will get the statement 38 is equal to 38. And I've restored balance to the force. I've restored balance to this equation. It is now true. Okay. So the addition principle is going to work that way. If I add something to one side, I have to add it to the other side. If I subtract something from one side, I have to subtract it from the other side. Okay. And the second principle that we have to learn and really understand is the multiplication principle. All right. And the multiplication principle says we can multiply or divide any non-zero. Now that's the important difference here. Any non-zero number to the equation as long as we do it to both sides. So we have to do that same multiplication or that same division to both sides of the equation. Otherwise, you've changed the problem and you won't be able to get to the solution. So as an illustrative example, we might have, let's say 10 is equal to let's say 100 over 4 minus 15. Right? I have this left-hand side and this right-hand side. And the equation says that they're equal. Well, our scale is balanced. Now imagine that I wanted to multiply something on both sides. So let's say that I multiplied this side by -2. So I'm going to just put -2 and I'm going to multiply it by this single number here. So maybe I'm going to wrap this side of the equation in parentheses, okay? And that parentheses will indicate multiplication. Well, that's going to be when I solve that part or simplify that part. Now it's going to be -20. And I can ask myself, is that going to be the same as this? 100/4 divided by -15. Okay. Well, I know that I sort of threw this out really quickly, but in my head, all I did was 100 divided by 4 is 25. And then -15 should take me back to 10. So originally, they were equal statements. But now they're not, because this equals 10. Okay, so I have this. And if I want to make them equal, right now they're unbalanced because I've only multiplied this side by -2. Well, if I want to keep them balanced, I'm going to have to multiply this entire side by -2. And since there are two terms here, the entire side of the equation gets multiplied by -2. But what that means is that I'm going to have to distribute it to each of the terms. Okay. So let me simplify this a little bit. And we could use order of operations to do this if we wanted to. We don't have to necessarily distribute it, but it would lead to the same result. So let me go ahead and do that. That would be, I'll start with the stuff inside the parentheses. 100 divided by 4 is the 25 that I was saying. -15. I can do the stuff inside the parentheses first if I wanted to. This should give me my 10. I still have my parentheses and this -2 that I just randomly threw into the equation to sort of balance it out. And then that gives me my -20, which is the same thing that, you guys can't see that, is the same thing that I got here, -20. So yeah, that checks out. That's balanced. I multiplied this by this side of the equation by -2, and I multiplied this entire side of the equation by -2. Does anybody have any questions about that? So that's another thing that's, I think, a little bit tricky for students. When I say you multiply a number by one side of the equation, I mean everything on that side. That entire expression gets multiplied by that single number. And so it might feel like, oh, you only multiplied -2 by one thing over here, but you multiplied -2 by two things over here. I understand and appreciate that feeling, but what this principle is saying is that if you multiply a number, a non-zero number, by one entire side of the equation, then you can multiply the entire side of the equation, the other side, by a number. And it doesn't matter how many terms there are. If you multiply the entire side of both sides of the equation by that number, that you will have a true statement, that your equation will still be balanced. Okay, that might have been a little bit confusing. I'll let you marinate on that one for a little bit. All right. Okay, so that might be a little bit esoteric. Now that we have those rules down, let's jump in and do some problems. So let's practice with some solving equations. Okay. Okay, so I have this equation and we're given the instructions to solve the following equation. I have -7x minus 4 is equal to x minus 7. Okay, now I did lull you guys into a false sense of security before when I was giving you things like x plus 25 is equal to 30, right? with those kinds of equations, it was really simple to look at the problem and just say, like, guess what the variable value was. But when you start to have more complicated and more operations in the equation, we need to rely on the addition and the multiplication principle to sort of guide us in the correct direction. So our goal for solving this, #goals, is to isolate the variable. We want to isolate the variable. In this case, the variable is x. And we're going to do so using these two principles that I've gone over briefly. So the addition principle says we can add or subtract anything to this equation as long as we do it to both sides. So we have a left-hand side over here. And a lot of times what I'll do just as a visual trick is put a little dashed line just to indicate this is our left-hand side of the equation and this is our right-hand side of the equation. Once you get confident and you sort of don't need to write this little dashed line, you can identify just by looking at it. You can use this sort of like as training wheels until you feel comfortable moving from the left-hand side to the right-hand side of the equation. But these are the steps that I would guide you towards. And we're going to think through this a little bit out loud. So what I want to do is get the variable x to be on one side of the equation so that I can combine like terms. A variable is a number, but we just don't know its value. And because a variable is a number, we can add or subtract it, we can multiply and divide it. We just won't know what the answer is, what the value is for that variable, but we can do operations to it. So for instance, if I wanted to move this or sort of take this x and get rid of it so I didn't have an x on this side, I could subtract x from x. Okay. Maybe that doesn't make a whole lot of sense up front, but let's think about the numbers then. Let's say that I wanted to get rid of this -4. What would I have to do to -4 to cancel it out or to like clear it out and get a 0?
+4.
I would have to +4, right? I would have to add 4. So what I could do is add 4 to this side of the equation. But the addition principle says if I add 4 here, I have to add 4 over here. And I'm going to line that up with the number that I know its value. Okay. So my first step is going to be use the addition principle, to get the constants on one side of the equation. It doesn't matter which side of the equation, but I tend to like to move the constants to the right-hand side. And it should be clear here in a little bit what I mean by move the constants. Okay. So I'm going to just do a line to indicate I'm moving on to the next line. When I do this operation, -4 + 4 we said is 0. So when we do that, we could just say that those cancel out. And I'll just drop my -7x down to the next line. Over here, I can treat this as -7 + 4. And that doesn't cancel out, but we should get -3. And I can just bring the x down. And now I can interpret this equation now as -7x equals x - 3. And because I've done the same thing to both sides of the equation, this is equivalent to the original equation, right? I haven't changed the problem because I followed the addition principle. Okay. Well, now the next step is going to be use the addition principle to get the variable terms on the other side of the equation. So like I said, this is just a number. I don't know its value. I can add, multiply, divide, and subtract if I wanted to. But what I'm going to do is, if I want to get rid of the x over here, I have to subtract x. So I'm going to subtract the x over here so that these will cancel out, because a number minus itself will be 0. If I do that to one side of the equation, though, I have to do it to the other side. And now I can just go ahead and simplify these expressions. A number minus itself is 0. So we can say those cancel out, leaving us with just -3. And if I owed somebody 7 apples, and now I owe them another apple, I owe them total 8 apples. So slowly but surely, this problem is looking a lot simpler. All right, so the last step here, now that we just have a number next to the variable, it's not very easy to say, okay, -8 times the number gives us -3. I won't be able to guess what that number is. So now I'm going to use the multiplication principle to isolate the variable. Okay, well, recall that -8x is equal to -8 times x. So I'm trying to undo multiplication here so that I can get the x by itself. What is the opposite of multiplication?
Division.
Yeah, it's division. So I can say that if I want just one x left, a positive 1x, then I can divide, and I'm going to write division as like a fraction bar. I'll divide both sides. I want to cancel out this -8 so that I have a 1, just one x remaining. I'll just cancel out by dividing by that -8. And if I divide -8 on this side, I need to divide -8 on this side. Well, -8 divided by -8 is just 1x. And -3 divided by -8 will be a weird decimal number. So let's just simplify this and call it a fraction. A negative divided by a negative is going to be a positive. And we're just going to leave it as a 3/8 since that doesn't reduce any further. So at the end of the day, we can just say the solution is x, because 1x is the same thing as x, is equal to 3/8. Okay, we're going to do another example. And, for the first one, it's always a little bit slow going. I'm trying to explain it with excruciating detail. This one's going to be a little bit sped up, but I want you guys to stop me if I do something that's confusing. Okay. So let me solve this one.
I have a question really
Yeah,
quick.
about this last one?
Yes, about the symbol, the 3/8.
Right here?
It's negative, and then you put positive, but we didn't do the operation yet. It doesn't matter.
So what I did is I said, if you have a negative divided by a negative, then that's just positive.
Okay.
So I've simplified it. And then when you put
just the symbols. Okay.
Yeah,
Okay.
these two symbols will make it positive.
Okay.
Good question.
Okay.
The same thing happened over here. I said -8 divided by -8 equals 1,
Yeah.
right? And if you're not sure about that,
No,
you can always,
I just get confused because we didn't did the division yet. We
yeah, we just left it alone.
just left the fraction right there. Exactly.
Yeah, because if we did negative, let's say -3 divided by -8 in the calculator, it would give you a decimal.
Yes,
And
positive.
we don't want a decimal answer.
Okay.
But you'll see that if we just simplify it by saying negative divided by negative is positive, that this 3/8
It has to be positive.
is
Okay.
the same positive value.
Yes,
Yeah.
I understand.
So it's
Thank
just
you.
simpler to write it as positive 3/8.
Okay. Thank you.
Yeah, you got it. Great question. Okay, so I want to solve this equation, 6. I'm just kidding. That couldn't possibly be the entire equation. It's 6 times 2x minus 1 is equal to 24. Yeah, again, it's another scenario where I can't just look at the x and sort of guess what the number is that goes inside. So remember our hashtag goals, if I could spell today, is to isolate the variable. There's going to be a few or several steps to do this, but you just have to sort of ask yourself each step of the way, what am I trying to do and how do I do it? What I would say is if you have something where it looks like you can distribute, that we want to start off by simplifying the left-hand side or the right-hand side of the equation. And remember, simplifying means distributing if possible, combining like terms if possible. So right off the bat, let me go ahead and put my training wheels on, draw this dashed line. There's no shame in it. I want you guys to get the right answer. So if you have to do this to start off with, then do it. The right-hand side of this equation is just 24. So there's nothing to simplify over here. We just have a single number. But the left-hand side looks a little bit more complicated. So what we'll do here is simplify by distributing the 6. So I'm going to have this 6. I'm going to multiply it by the 2x, and I'm also going to multiply it by the -1. So I should be getting now on this next line, 6 times 2x should be 12x, and 6 times -1 will be -6. That is equal to 24. Okay. Now, simplifying one side of the equation doesn't change the value because this expression is the same thing as this expression. We've just written it in a simpler form. It'll be easier for us to understand. So starting here on this new line, we can say, well, we want to isolate the variables. So get the numbers or the constants, the things that don't have variables, move those over to the right-hand side of the equation. So I'll use the addition principle. I like to say collect the constants. So if I have a -6 over here and I want to get rid of this -6 so that the 12x is by itself, what will undo -6? What is the opposite of subtracting 6?
Add 6.
Add 6.
Add 6. Yeah. So every step along the way, you're asking, how do I get rid of this thing? What is the opposite operation? So I'll add 6 here, which means I have to add 6 on the other side. I'll go ahead and draw a line and say, okay, I need to do this operation. -6 plus 6 cancels out, leaving me only with my 12x left over. 24 plus 6 should be 30. Any questions? Any craziness happening here? Or does it all sort of make sense? Okay, well, there's nothing, the variable term is isolated, right? I don't have to move anything else because I have the variable term on one side, I have the constant term on the other side. So once you have it where the variable term's over here, the constant term's on the other side, then you can move to the multiplication principle. And you might call it the division principle, but we'll divide something to get the x by itself. So you're always using that multiplication principle sort of last to isolate the variable. So again, we might just tell ourselves, recall that 12x is equal to 12 times x. So how do we undo multiplication? Well, we'll just divide. We'll divide this side by 12 and divide this side by 12, right? We're dividing by 12 because we want to cancel out this 12. 12 divided by 12 is 1. So we can say that these, in some sense, cancel out, leaving us with just x is equal to whatever 30 divided by 12 is. Well, you'll feel tempted to throw that into the calculator, but we want to keep our answers as fractions unless told otherwise. So we need to reduce this. So what you might say is that 30 is 6 times 5, and 12 is 6 times 2. Now you could break them down into all of their prime factors, but I'll leave the reducing fractions to you guys. If you reduce them to just factors where you have a common factor here, you can cancel out that common factor. And now our answer here is just x is equal to 5 over 2, and that's the solution. Okay, let me do one more example. We want to solve this guy. And this guy is 3 times 2z minus 5 is equal to 5 times z plus 4. Okay, so I'm going to walk you guys through this one. Again, our goal is to isolate the variable, but this looks kind of crazy. Let me go ahead and sort of visually separate. And again, you'll be able to do this without drawing a dashed line at some point, but if you're not there yet, go ahead and draw a dashed line. It'll help you out, I guarantee it. We have our left-hand side of the equation over here and our right-hand side of the equation here. You always want to make sure that before we start this, that the left-hand side and the right-hand side are simplified. So we have this expression over here that we can simplify and this expression over here that we can simplify. So 1, simplify the left-hand side and the right-hand side. So I'll just take this 3, distribute it here and here, take this 5, distribute it here and here. You'll want to be careful here because I noticed that a lot of students will make mistakes. They'll multiply the first number, but not the second one. So just be sure that that doesn't happen, that you distribute it out completely. So 3 times 2 is going to be 6z. 3 times -5 is going to be -15. And that's going to be equal to 5z plus 20. Is everybody okay with that? Or is anybody not okay with that? Okay. The second step is to collect your constants. So what I would say is I'm going to move this 15 over to this side. And the way I'm going to do it is ask myself, minus 15, what is the opposite of that? I want to add 15 to both sides. So now this should cancel out since negative 15 and 15 makes 0, leaving me just with 6z. And on this side, I have my 5z still, but 20 plus 15 will be a positive 25, 35. 3. I will collect my variables now. And if I move my constants over here, like I canceled this side and I moved something over here, then I want to cancel my variable on this side and move it over here. So I'll do that by saying this is a positive 5z. If I want to get rid of it, I need to subtract 5z, and I need to do that on both sides. Well, this and this, right? If I have 5 apples and I eat 5 apples or give away 5 apples, I have nothing left except for this 35 down here. So I have a positive 35. You don't have to bring the plus sign down. We understand that it's positive. If I have 6 apples and I eat 5 of them, how many apples do I have left?
1.
1. I have 1 apple, or I have an apple, so I should still have a z here. You don't have to write a 1 in front of the variable. We understand that we have a z here. Well, since the variable is completely isolated, I have z is equal to 35. That's all I was looking for. What is the value of z? So I'm done here. I didn't actually have to use, in this particular problem, I didn't actually have to use the multiplication principle. The addition principle did us just fine. Okay. So I want to take a break just to let you marinate on this a little bit. Let's take 10 minutes and we'll come back and then do some more of these problems. So let's say at 1:45. Still waiting on a few people. But let's take this time to say to just talk about how did you guys feel about some of these problems. It's okay if you didn't finish all of them. I think that right now, especially if this is like your first exposure to solving equations, then it'll take a lot of time. It'll take a lot of looking back at the notes to refer to like, okay, how do I do this part? How do I do this part? How do I do the next part? And if you're one of the students that is non-traditional and has been out of school for a while, then it might take a lot more flipping back and forth between your notes. But I guarantee you that that's part of the process. Learning algebra, learning math, you feel like you're drowning the entire time. And just when you start to feel like you're understanding something, you learn something new and you're thrown into a deeper end of the pool. So don't beat yourself up too much. Have some compassion for yourself and just realize that that is part of the process. And communicate with me whenever I ask. If you guys have questions, don't be afraid to ask, because you need to, be accountable to yourself to get the most out of this education, right? Because you're paying for it. You're paying for my services. You're paying for my instruction. So yeah, did anybody have any questions, thoughts, feelings about these? About any one of these problems in particular that you want to like go over? I'm not going to have time to go through each of them.
The second one.
The second one. Okay, I'll put a little star next to that. Did anybody want me to go over another one?
Can you go over 3?
Sure.
And how about 5?
Yeah, 5. I think those will be good. Well, let's just reflect a little bit. I don't know if I can say raise your hand. Who all was having some trouble with this, and like, where do you think the confusion is in your brain? Or like, what is the confusing thing about it? This is not me to like put you on the spot so that we can all like take turns lobbing tomatoes at you or something. This is just so we can like work it out. I'm sure that your classmates, the quieter ones, are just as reluctant to speak as you are. So let's get the most out of this, and let's all participate.
Just because to me it's the negative.
Yeah.
X, I don't know really what to do,
Yeah.
because if the answer is supposed to be x equals 1/3, right? But I don't know the symbol, if we had to put positive x, or I really don't know. I'm like,
Yeah, so it turns out that the answer here is not 1/3. It looks like it's already solved, right? Like that's the confusing thing.
yes, exactly.
So the confusing thing is that it looks like it's solved already, but it's not, because when we solve these equations, solving means that we have x is equal to some number, right? Not negative x is equal to a number. We don't want to know what the negative quantity of x is. We want to know what the quantity of x is. Okay, so that still might not seem very clear. So let's think through this problem. We have a negative number, and then this negative sign and this number makes it turn into a positive 1/3. So you might be able to just guess this one, that a negative sign here and some number, or multiplied by some number, makes it a positive 1/3. If I put it to you that way, can you guess what this number should be?
Negative.
Negative, right? It should be a negative, because a negative and a negative will give me a positive. Okay, but so you could do that and say, okay, a negative times something gives me a positive over here. So that means that x by itself, the number I'm going to plug in, has to be negative 1/3. So I can take that and plug it in here and get that true statement. But typically what we do, when we're instructing students to solve this one, is we said that negative x is the same thing as negative 1x. So let's just rewrite the equation as -1x is equal to 1/3. And if we do that, then we can just use one step, the multiplication principle, to divide both sides by -1. Well, -1 divided by -1 is going to be +1, so we can say those cancel out. So we have x is equal to, anything divided by 1 is going to just be that thing, right? So we can just leave this as 1/3, but since we have a positive divided by a negative, then our answer is going to be a negative. And this divided by 1 is just 1/3, is just itself. So we have x equals a number, right? So just make sure that when you're solving for these things, that you have x by itself, not negative x. It needs to be a positive x.
Okay, thank you.
Yeah. Is that still sort of confusing to some of you guys? Does anybody have any questions about that? Okay. Well, let's look at, this was number, that was number 2, right? And then we said, let's look at number 3. Number 3 was -3x minus 5 minus 6 times x plus 1 is equal to 3x plus 5. Okay, so I'm going to do it this way. Somebody tell me what the first step is. Tell me what to do.
Distribute.
Yeah. So remember, when we're going through this, if we have complicated stuff on the left-hand side and complicated stuff on the right-hand side, we want to simplify as much as we can. So there's nothing to simplify on the right-hand side because these are not like terms. I can't combine them. So I'm just going to leave this alone. So maybe I'll draw my little dash line here just to demarcate the left from the right. And then the first step, yeah, I'm going to distribute. And I'll distribute that -6 here and here. And every time I distribute, I want to collect or combine like terms when I'm done with that. So this should be -6x minus 6. Is anybody confused about the distributing part? Once you've distributed, you can drop the parentheses. You no longer need them. We're just going to bring these two terms down. -3x minus 5. And all of that is equal to 3x plus 5. Okay, so the right-hand side of the equation still is simplified, but the left-hand side is looking a little messy. We're going to want to combine like terms to clean this up. Okay, that's how you need to think about it. We want to clean up the workspace. So what I like to do is I will sort of circle my like terms. So I have -3 minus 6x, -3x minus 6x, sorry. You can think of that like -3 apples minus 6 apples. That means I owe -9 apples. Same thing over here, -5 can be combined with -6. So if I combine them, -5 minus 6 should be -11. Okay, and I know I'm sort of talking a little fast right now. Does anybody have any questions about that part? Cool. So we're moving right along. 3x plus 5. Still haven't done anything at all to the right-hand side. I'm just bringing it down. Okay. At this point, we can start moving stuff from one side of the equal sign to the other side. And what I like to do is move the constants first. So if I want to get rid of -11, I'm going to do the opposite and add 11, but I have to do it to both sides. So my next line, because these -11s cancel, should say -9x is equal to 3x, and then 5 and 11 should make +16. Any questions up to this point? Okay. Now I want to move the variable over here so that I have my variable terms collected. So I want to cancel out this term. So I will subtract 3x from both sides. And since this variable term is just like a number, I just don't know its value, then I can say I have 3 apples and I ate 3 apples, so I have no apples left. That cancels out. All I'm left with is this 16. On the other side, I have -9 apples, so I owe 9 apples, and then I owe 3 more apples, so I owe a total of 12 apples. The last step is going to be using that multiplication principle. And I know I'm saying multiplication, but you should be thinking the last step is to divide something. And we want to get x by itself, so I'll just divide this by -12 and divide this by -12 so that these 12s cancel, the -12s. That'll leave me with x is equal to 16 over 12, but it's a negative. So let me reduce this. 16 is going to be 4 times 4, and 12 could be written as 4 times 3. So I know that these 4s can cancel. So I should get -4/3 as my answer. Any questions there?
In the steps, sorry,
Yeah.
it was distribute, combine, we did the addition, then what was the fourth that we did?
Yeah, we distribute it, we combine like terms, then we use the addition principle to add 11 to both sides. We use the addition principle again to move the variable over to one side. And then that final step is the multiplication principle. But
Got it.
that's generally the progression of the steps. Sometimes you only have to do the addition principle once. Sometimes you can go straight into the multiplication principle, right? So this is not a thing where it's going to be the same steps over and over. The thought process is, if you have an expression that's complicated, simplify it. Once we distribute and combine like terms, we have a simplified expression. Then you want to move the constant terms, or the things that are just plain numbers, over to one side by undoing them or doing the opposite operation to both sides of the equation. You'll want to then move the variable to the other side. So I can't tell you that it takes like X amount of steps, because some problems take 3 steps, some of them take 4 or 5 steps. You just have to sort of get in there and figure out what the rhythm is. And but the general principles remain. The rules are the same. Okay.
Can you move your paper up just so I can see the bottom?
Yeah. So that last step, I use the multiplication principle to divide the same number on both sides so I can isolate the x.
So, and then you wouldn't, I mean, 4 over 3, wouldn't that be 1 1/3?
1 1/3 if I wanted a mixed number, but I prefer improper fractions.
Okay.
So you'll always use a fraction or an improper fraction as your answer unless MyLabs Plus tells you otherwise. Rarely does it tell you to use a decimal. Rarely does it tell you to use a mixed number, but just read those instructions.
Okay.
Okay. Let's do number 5. Number 5, número 5. That one was a monster. And this actually might work better if we did it this way. So this is 4 times 3x plus 5 plus 7 times x plus 1. All of that is equal to 7x plus 5. All right. This one looks intimidating. But sort of like our order of operations, we want to simplify things using our grouping symbols that are the most internal grouping symbols. So I'm gonna go and say to myself that the right-hand side of this, let me go ahead and do that little dividing line. Here's my left-hand side and my right-hand side. The right-hand side is simplified. I can't combine these terms. There's nothing I can do over here to make it any simpler. So I'm gonna look at my left-hand side and say that this thing looks crazy, right? How do I simplify this? Well, I'm gonna start at the most internal set of parentheses. And since I can't combine the x and the 1, I'm gonna take this positive 7 and I'm gonna distribute it. Okay, so when I do that, I should get 7x plus 7. When I distribute this, I no longer need these parentheses, but I still have the brackets. So I'm just going to bring everything down. I'm going to bring the 3x plus 5. This was a plus 7, so this was a positive 7x plus 7, and I'm going to enclose that in brackets. Okay, does anybody have any questions up to that point? Well, now the brackets still look crazy, right? The expression inside the brackets. So in my head, I'm going to say this is still really messy. Let's clean it up by combining like terms because that's the only thing I can do inside the brackets. So the 3 and the 7x, since those are like terms, I can combine them and it'll be simpler to just call that 10x. Similarly, it'll just be simpler for us to say that plus 5 and plus 7 gives us positive 12 or plus 12. And I'm leaving that in the bracket. So now the bracket stuff is simplified. I just have to deal with this 4 on the outside of the brackets. Notice I'm not touching the right-hand side at all, just working on simplifying the left-hand side. The next step is going to be, since I can't combine these terms inside the brackets, I can move outside and start distributing this 4. So I'll go ahead and distribute the 4 to this term and this term. So I'm multiplying. So I should get 40x plus 48. And since now this is completely simplified, I can bring my right-hand side of the equation down and we can actually start doing some work on this equation. All of this stuff up to this point, we were just prepping and simplifying the left-hand side of the equation. Now we can start solving. And when I think about solving, I'm thinking about moving things across the equal sign. Okay, so if I want to move this number over here, I have to do the opposite of what I see, and that means I need to subtract 48 on both sides. And that means I can cancel these guys out. And this 5 minus 48 should give me negative 43. So I'll just bring everything down. 7x is over here. So now 7x minus 43 is equal to this 40x. Okay. So all of the numbers that don't have variables attached to them, they're over here on the right-hand side. So let's move this variable term over to the left-hand side by canceling it out, by doing the opposite. If this is positive, I'm going to subtract. I'm going to do the opposite so I can cancel that out, and I'll do it to both sides. And I don't know about you guys, but I'm really loving this purple and pink color scheme. It's really doing it for me. So I'm going to get rid of these 7x's. I'm going to bring down the negative 43 here. And then this will be 40 apples. I ate 7 of them, so I should have 33 apples here. Any questions up to this point? Okay, well, I feel like I've run out of space. So what I'm going to do is, I routinely do this. I'm going to draw an arrow, give myself some more space. And we're just working with the equation 33x is equal to negative 43. Well, the last step is always to divide something, or tends to be to divide something. So let's just get the x by itself by dividing 33 on both sides. The 33's cancel, so we have x by itself. And now x is equal to negative 43 over 33. And that fraction, my friends, does not simplify. I don't think so. 43 divided by 3. Nope, that doesn't work. And 11 won't work either. So we're good to go.
And can you at least give us the answers to the other problems that we didn't work out?
Yeah, let me,
Come to the right answer.
for sure. Let me write these down. Okay, so I for the first like 5 minutes or so when you guys were in the breakout rooms, I worked these out really quickly. So if I made a mistake or if you get something else, feel free to challenge me on them. For number 1, I got y equals negative 12 over 7. For this one, I got x is equal to negative 1/3. For this guy, I got x is equal to, was that number 3? Negative 4/3. For this guy, I got x is equal to 11 over 2. And for this guy, I got x is equal to negative 43 over 33. Let me go ahead and move this up so you can see. Take a second to write those down. Okay. Okay, so I'm assuming that you guys have that written down. Anybody need more time to write it? Okay. So I did want to talk about one more topic, but I feel like we've gotten a lot in today, a lot of practice, probably have created more questions in your mind than anything. But again, this is part of the process. You just got to get into the homework, give yourself the time, the mercy to like get in there and make mistakes. Come to Math World, come to my office hours, so that we can figure out, you know, where those mistakes are happening and start to correct them, because it's going really fast. I'm sure that for some of you, today's lecture might have felt like we went 0 to 100 real quick, but that's just how it's going to be because we only meet twice a week. So you're going to have to do a lot of the heavy lifting outside of class, but just remember you have that support. And I do want to show you guys one thing. Let's see. Let me go ahead and share my screen real quick. Boom, boom, boom. Okay, so on the home page for Canvas, if this loads quick enough, what I've done is I've created a Zoom session that correspond to my office hours so that you can now drop in during these times as well. I'm available a lot of time throughout the week because I'm in math. When I'm not in class, I'm essentially in Math World. So let's see. My computer's been acting slow. So if you scroll down here on the home page, it says virtual office hours, Monday and Wednesday at 3:30 to 6 p.m. Email to set up an appointment. But the email to set up an appointment is really just a courtesy, right? In case I have to be taken away to do something else. And if you drop in there and I'm not there. But in any case, the Zoom link for those office hours is posted right here. Okay. So not only am I available for What is happening? Oh, I see what happened. I'm gonna stop sharing. I think. There we go. So that Zoom link is there. So if you need to drop in, I'll have that open on Monday and Wednesday evenings if you need to talk to me that evening while you're working on your homework. But if you look at my Math World hours, I am available Monday through Friday. So and like on Tuesdays and Thursdays when we don't have class, I'm there from 9:30 in the morning to 3:30 in the afternoon. On Fridays, I'm available from 8 to 2 in the afternoon. So like long periods of time where I'm just waiting for either you guys or some other students from other classes to drop in and get some math help. So just make sure you're using that support because again, it's just going to pick up speed from here. Next week, we're going to be learning about graphing linear equations. So what we've been doing, solving these one variable equations, are actually linear equations. We can draw a picture of them if we wanted to, and that's what we're going to get into next week. So make sure you get in there, get your practice in MyLabs Plus, make the mistakes, come to Math World, send me messages, do what you got to do. But as long as you're, giving it that old college try, I am here to support you, and I'm here to help you succeed in this course. So don't forget that. If you have any questions, just hang back after I let you guys go, but you guys are free to go otherwise.
Where do we find these recordings of these lessons? Like if I wanted to go back from Tuesday
Yeah.
to refresh, where would I find that recording at?
So in our Canvas page, under modules,
Okay.
let me see. I'm going to share my screen. So for those of you who are still hanging back, under modules, we're just in module 1 right now. We're doing arithmetic with real numbers, really. And right here at the top, it says module 1 lecture videos. If you click on this link, it takes you to a page where I'm compiling all of the notes that I take during lecture, all the stuff that I write down on a piece of paper.
Okay.
Those notes are provided here.
Okay.
And the lecture videos are provided underneath that. So if you scroll down, on Monday would have been day 4 when we talked about algebraic expressions. The notes are here and the YouTube video is here.
Okay. Thank you very much.
Yeah, you got it. Any other questions?
Sir, on the homework, I think it's under My Labs Plus or My Lab something, right?
Yeah.
So it doesn't let you move on until you at least pass them all, right?
You have to get an 80% or better on the previous homework to open up the next one. So if you're still lagging behind and you're falling behind on like the fractions homework, for instance, and you need to get caught up, you won't be able to get caught up until you get those assignments done, right? It's sort of a preventative measure so that you don't fall behind. But if you do fall behind, you need to contact me and we need to like get you up to speed.
Yeah, because I think the last homework, not this one, but the last one, I kind of having trouble on it.
Yeah.
I got some other questions right, but some of them I need a little help. But
Yeah.
all of them I got hundreds on. It's just the last one I'm kind of struggling on that one.
Yeah,
So-
for sure. And let me go ahead and share my screen for those of you guys that are still hanging around. Virtual Math World, right? If you click on the link for Virtual Math World, if you're having trouble on your homework and it's outside of my office hours or outside of my Math World hours, because I know that they put me early in the morning to the early afternoon, there's plenty of other tutors available here. And Pete, the coordinator of Math World, just updated this page. And once it loads, but he updated it so that you can see where we are on Monday, Tuesday, Wednesday, Thursday, and Friday. And I think that the Saturday hours are there for people who are there on Saturday. But if you scroll down, the table has been updated somewhat. Yeah, there we go. And you can see where each of the tutors and instructors are when they're available Monday through Saturday, right? And you can see that there are some instructors here, Deborah, Mario, and Roseanne, that are available on Saturday if you can't get in during the week.
But now I don't see where you click for the Zoom call.
You'll click on the name for the Zoom.
Okay. Okay.
Yeah.
Sir, you said you had one Friday at 8 to 2, right?
Yeah, I'm available from 8 to 2. But Kelly, you came and visited me in Math World, right?
Yes, I did.
If you come into Math World like Kelly experienced, I might be tutoring other students. So it's sort of like we take turns going back and forth between each of the problems. So you have to be a little bit patient. But there's plenty of times where you will drop into my Math World hours and you're going to be the only one there. So sometimes if you luck out, and it happens quite often, you get that one-on-one tutoring that you're probably looking for. So make sure you take advantage of it.
And so did you add
Either with
another
me or somebody
assignment?
else. What's up?
Have you added another assignment to review like the work we did today?
Yeah, there's an assignment in MyLabs Plus. I'm going to put out an announcement right now just to make sure
Okay.
you guys it's your responsibility to go into MyLabs Plus and make sure that you're checking on those assignments, but I'll routinely either at the end of class or the end of the week, like our lecture on Wednesday, I usually send you guys an announcement once a week to say like, these are the things that you need done by Sunday.
Okay.
So make sure that you check those announcements. And those announcements can be found here in our Canvas page under announcements. Okay. Does anybody have any other questions?
So the only assignment we have that's due Sunday is that one assignment, right?
You have section R2, which we covered on Monday, and what we covered today is section 1.1. So those two are due Sunday. But there's two other discussions that I created that I completely neglected to tell you guys. Check the announcement. They're very brief YouTube videos that I think are super helpful for understanding the multiplication and addition principle. They're silly videos, so bear with me. I think that they're funny, but they're a little bit on the zany side. They will help you understand it a little bit better. So 2 homework assignments, I believe, in MyLabs Plus that are due on Sunday, and then these 2 tiny little discussion posts. But check the announcement that I'm going to post here in a bit once I get the video and the notes uploaded for today.
Okay, because I saw that there's one that's posted in MyLabs Plus. I don't think you posted the other one yet, right?
It should have opened at noon today, so
Okay.
if you check back, you should see those 2.
I checked it yesterday, so it's probably.
Yeah. Any other questions? Well, if there are no other questions, you guys are free to go.
Okay, sir. Have a great day.
Enjoy your weekend.
Thank you.
Yeah.
Thank you.
See you guys in Math World.
I'll be there tomorrow.
All right. Looking forward to it.
Thanks.